All right, guys, today we're going to be doing 1.1c. So if you have not read the top of 1.1c here, I'm going to have you guys start this right here, reading it, pause it. I want you guys to read and highlight the important information in 1.1c all the way down to, let's just go to the end of the page here, okay? So I want you guys to go ahead and read and highlight important information in this page on page 14. And we're going to go ahead and start with number 2 together, okay? So it says the following is a model of this equation, 5x minus 8 minus 2x equals 4. Create this model with your own tiles and solve the equation. Okay, I told you guys, absolutely. I would love to help you with these tiles if this helps you out. Okay, but I'm going to show the math down below the solving actions before doing that. So your first step is to always look for the distributive property. Okay, is there a distributive property in here with parentheses? No. So we're trying to solve for x in this situation. So here's what I'm going to teach you guys. I always draw in railroad tracks around my equal sign just to stay organized. Your first step is going to be to cover up the railroad tracks in that 4 with your hand and say, okay, is there anything on this left-hand side that can be combined because of like terms? Yes, this 5x and this negative 2x can be combined. What is 5x minus 2x? Well, that would give me 3x minus 8 equals, was it 4? Yes, 4. Now, my goal is to get everything away from that x. So to do that, I'm going to add 8 to both sides because I'm trying to solve for x. So 8 plus 4 gives me 12. Now I have 3x equals 12. How can I solve for x by itself? What is this right here? Technically 3x, is that adding, subtracting, multiplying, or dividing? Well, it's multiplying. So I'm going to do the opposite. I'm going to divide by 3. 12 divided by 3 is 4. So x equals 4. So really what we're doing is we're undoing PEMDAS and doing PEMDAS in order to help us solve for the variable. B says verify the solution in the space below. Verify is another keyword. Just basically means prove it. Okay, so if I have 5x minus 8 minus 2x equals 4, they want me to plug this 4 in to see if it works. So 5 times 4 minus 8 minus 2 times 4 equals 4. So we get 20 minus 8. Well, what's 20 minus 8? That's 14. 14 minus 8 should be 4 as well. Wait, 5 times 4 is 20. 20 minus 8, sorry, 12. And then 12 minus 8 more is 4. Is 4 equal to 4? Yes, so we know that works. We verified it. Okay, number 3 says model and solve the following equations, show the solving actions, and verify your solution. Again, I will model for you in class if you would like me to. We're going to go ahead though, and we are just going to start by solving the equation. So draw on your railroad tracks. Look on both sides. Is there anything we can combine on the left-hand side of the railroad tracks? Yes, these x's. 4x plus 3x is 7x minus 1 is equal to 6. Okay, my goal is to get x by itself, so I'm going to move everything else over to the other side. What you do to one side of your equation, you have to do to the other. So how can I undo a negative 1? Well, the opposite of subtracting 1 is adding 1. So if I add 1 to one side, I'm going to have to add it to the other, just like the balance beam activity we did in class. So now I'm left with 7x is equal to 6 plus 1 is 7. All right, how do I get x by itself? Well, what operation is 7x? That's multiply, right? The opposite of multiplying is dividing. So I'm going to divide both sides by 7. So I get x is equal to 1. Let's go ahead down and do number 5. Draw on your railroads. First step, combine your like terms. 2x minus x will give me x. I'm left with x plus 4 equals negative 8. I want to get x by itself, so I need to get rid of this 4. The opposite of adding 4 is going to be to subtract 4 on both sides. I am left with x is equal to negative 12. We now need to verify. Plug it in. 2 times negative 12, because I plugged it in there, minus 12 plus 4, they want to know if that equals negative 8. 2 times negative 12 is negative 24. Actually, it's positive 24 because a negative times a negative is a positive. Hold on. That should be negative. Positive times a negative is a negative. Minus 12 plus 4 equals negative 8. And I found my mistake. So, yes, 2 times negative 12. Let me get my eraser here. 2 times negative 12 will give me that negative 24, right? Well, now they have minus a negative 12. So look how those parentheses are extremely important there. There's a double negative. That was a negative, and then my x was negative 12. So now a negative plus a negative, a double negative, gives me a positive. So those parentheses are really important if you have a negative integer. All right, so negative 24 plus 12 will give me that negative 12. Negative 12 plus 4 equals negative 8. Negative 8 equals negative 8. So yes, I know that works. All right, so here's what I'm going to have you guys do. Take a look at number 4, what looks different on this one. Some of you might freak out. You might be saying, whoa, Miss Swiderski, look at this. They flipped the numbers and the equal signs. A couple things you can do. Same thing, guys. Go and draw on your railroad tracks. Okay, 3x minus x gives me 2x plus 4 on the right-hand side of my railroad tracks. Bring down that 10. My goal is to get my variable by itself. Always want to get the variable alone, find its value. So we want this x by itself. So I'm going to subtract 4 on both sides. 10 minus 4 gives me 6. 6 is equal to 2x. Divide both sides by 2 because we want to get x by itself. We get x is equal to 3. Copy that down for me. Now hear me out. I've also seen some 8th graders do this. Some 8th graders say, Mr. Dursky, I don't like how that looks. So due to the commutative property, okay, what you learned, I think it was 6th grade, commutative property says you can rewrite if I have 3 equals 2 plus 1, can I also say that 2 plus 1 equals 3? It's the same thing. I'm just flipping that. Absolutely. So watch this. You can rewrite this as negative x plus 3x plus 4 is equal to 10 if you want, and just flip that. If you like this idea of just having one number on the other side of the railroad tracks on the right hand side, you can do that as well. Okay, I'm going to have you guys try number 6 on your own. Okay, circle your answer, and we're going to come down to number 8. Number 8. So to solve the following equations, let's go and try a couple. Draw in your lines on your railroad tracks. First step, combine those like terms. Negative 7x plus 5x is going to give you negative 2x. Bring down that positive 3 equals negative 9. I'm going to subtract 3 on both sides. I get negative 2x equals negative 12. Divide both sides by negative 2. Remember, a negative divided by a negative is a positive. So you get x equals 6. If I plug that back in, negative 7 times 6 is negative 42. Plus 30 is negative 12. Negative 12 plus 3 is negative 9. Yes, that works. Let's go ahead and try 10. 10's a little different, decimals. All right, I'm going to rewrite this. I get 0.5b plus, instead of 2b, I'm just going to write 2.0b just because of place values with those decimals. When I combine those, you're going to get 2.5b, or 2 and 5/10 b, equals negative 50. I'm going to divide both sides by 2.5. When you type that in the calculator, we get negative 50 divided by 2.5, 20. So it's going to be negative 20 because a negative divided by a positive is a negative. So b equals negative 20. All right. I'm going to have you guys try number 9 on your own. Number 10, I want you to find the mistake here and write the mistake, what they did incorrect, down here, and solve correctly. All right.